Okay, so here we've got a sum, and we want to rewrite it using summation notation. So we want to write something like this, where we have a sigma, we have k equals some number, there's going to be a number up here, and there's going to be our, whatever our expression is here. So we can kind of just look at this a little bit and maybe build it as we go. So we should notice a pattern, right? That's really the big thing here, is pattern recognition. Do we see what's going on? The first thing that jumps out to me, at least, is that these values in the sum are going back and forth between positive and negative, positive, negative, positive, negative, positive. So that indicates to me that we need to involve some power of -1, right? If we're going to start at k equal 1, this doesn't exactly matter, but I think all of them that I looked at in WebAssign, they all have a 1 down here. So if we put a 1 down here, we need to say what the power needs to be to make it be a positive number for k equal 1. So if I just had a k up here, and I were actually going to do this sum, for my first term I would put a 1 in here, and that's going to make this negative. That's not what we want, though. We want this to be positive. So in order to make this to be a positive number, I would want the exponent to be even. So if I put in a 1, that's an odd exponent, but I can just add 1 to it, and hey, now it's even. We could have also put -1. That would have had the same effect, but I don't really think it exactly matters here, so we're just going to write +1. Okay, so we could go down the line, right? So if this is going to correspond to k equal 2, we would want it to be negative. So -1 raised to the power of 2 plus 1 is 3, so -1 to the third power, that is negative. So that did work for this. So that's good. This part, that looks like what we've got in our numerators all the way around. So we can take a look at what's in the denominator now. So again, it's just pattern recognition, right? Do you see the pattern? We got 4, 8, 16, 32, 64. So without too terribly much stretching our imagination, we can see that they're just doubling every time. We can see that they're all powers of 2, don't we? Right? 4. We could probably write this in a couple of different ways, but the thing that's jumping out to me is that this is a power of 2, right? So for our first term, we would want to write a 2 to the second power. So if I want this to be the second power, I can put k plus 1 right there. So now, if I do k equal 1, then that would correspond to this guy being 2 raised to the 1 plus 1 power, so that's 2 to the second, which is 4. So I've got my negative stuff represented here. That oscillates between negative and positive, and then I've got powers of 2 represented down here as well. So we're almost done here. We just need to say where we stop, right? So if this corresponded, and we could probably check ourselves down the line too. Let's check to see if it works maybe for the fourth term. So this is the first term, second term, third term, fourth term. So if I put k equal 4, I ought to get this, right? Well, if I put k equal 4, I'm going to have 4 plus 1, that's 5. -1 to the fifth, that is negative, so that's good. And then if I would put 2 to the 4 plus 1, that's 2 to the 5. And 2 to the fifth, that is 32. So yeah, we're in good shape. So that checked out. So that's the fourth term, fifth term, sixth term, seventh term. So seventh term. And that is that. Looking at the assignment on WebAssign, it's going to give you this number, but you just have to come up with where you stop, and you're going to have to come up with this stuff. So a couple of things here. We noticed that when we oscillate back and forth, negative, positive, we need to have something like this in the picture. And then we just noticed the pattern that these were all powers of 2. We could have also maybe put something different here, like 4 involving a product involving 4, right? This is 4 times 2, 4 times 4, 4 times 8. But I think that this is probably the easiest way we can do that.